Solving quadratic equations by roots. All right, so previously we have looked at solving quadratic equations by graphing. And here's an example of a graph where you can look at it and you can approximate the answers. This one's a negative 1.3 maybe, and this one's 3.5 maybe, but you can't really find the exact answer from the graph. We've also looked at solving quadratic equations by factoring. Unfortunately, no matter how hard you try, this one doesn't factor. So solving by factoring does not always work because not everything factors. Even though we can't factor, we can see that there are answers, but the best we can do by graphing them is approximate them. So we're going to learn some different techniques for solving quadratic equations, and the first one is called extracting roots. So let's take a look at some examples. X squared minus 9 equals 0. I'm actually going to solve this one twice. I'm going to do it the way we learned to do it before, which is to factor. And we notice that this factors as x plus 3 times x minus 3. So we have x plus 3 equals 0, x minus 3 equals 0, so x equals negative 3, x equals 3. That's nothing new. That's what we've done in the past. The big thing I want to point out to you is when you have an equation with an x squared, you should almost always get two answers. Alright, so now let's solve this one by using square roots. To use square roots, we rewrite this equation as x squared equals 9. Then the opposite of a square is a root. So we do a root. And here's the mistake a lot of people will do. They'll write x equals 3. But we know x equals 3 is one of the answers, but it's not both the answers. And here's the key. Back here when I did square roots on both sides, I need to remember that every number has two square roots, a positive one and a negative one. So my answer traditionally is written as x equals plus or minus 3, which is the same as x equals 3, x equals negative 3. So that's what we mean by solving using square roots. We use square roots. The big key is to remember there's always two answers, a plus and a minus. Alright, so let's do a few more examples. 5x squared minus 15 equals 0. I can't just go ahead and take square roots. What I need to do first is a couple steps of algebra to get this x squared all by itself. You always need the piece with the square alone first. In other words, add 15 to both sides. The x squared is still not alone, so I'm going to divide both sides by 5. X squared equals 3. And then I take square roots of both sides. When I take square roots on both sides, I get x equals plus or minus. Don't forget that. There's always two of them. Square root of 3. And unfortunately, square root of 3 is not a nice number. So I leave my answer exactly in that form. Alright, let's try a little bit more complicated one. But not a lot more complicated. This time I had this thing with a parenthesis and I have a square on it. And that's okay. I need to get this thing with the square by itself. So I need to get this parenthesis alone. In other words, divide by 4. X minus 3 squared equals 8. And then I'm going to square root both sides. So x minus 3 equals plus or minus square root of 8. Now, while square root of 8 is not a nice number, square root of 8 can be simplified because it can be written as 4 times 2. And of course, the square root of 4 is a nice number. So this is plus or minus 2 square roots of 2. However, that's not our final answer. Our final answer is we got to get the x all by itself, which means we need to add 3. So traditionally, we would write our answer as x equals 3 plus or minus 2 square roots of 2. I'm going to write that again because it looks ugly. 3 plus or minus 2 square roots of 2. Now, when you go to enter your answer into the computer system, you're probably going to have to type one answer as x plus 2 square roots of 2, and then you'll have to type another answer as x equals 3 minus 2 square roots of 2. Most computer systems that I've seen doesn't allow for this plus and minus system, plus and minus symbol. So be ready to have to type in two answers like so. Means the same thing. Alright, just a couple more examples. 4y minus 5 quantity squared equals negative 36. Alright, this one's okay because here's our square. but it's already all alone. There's nothing being added, subtracted, multiplied to it. So we go ahead and do square roots on both sides. 4y minus 5 equals plus or minus square root of negative 36. But the square root of 36 is a nice number at 6. And then, because we have that minus in there, we see we get complex answers. So this is plus or minus 6i. And that can happen. Sometimes when you solve quadratic equations, you do get imaginary answers, and that's okay. Now we want to get the y all by itself, so I add 5 to both sides. 4y equals 5 plus or minus 6i. And then finally, I divide by 4. So I have y equals 5/4 plus or minus 6 over 4 reduces to 3/2 I. Alright, so don't let that worry you too much if you end up with complex answers. That's okay. Not a big deal. Alright, again, here's our thing that's being squared. It's not alone, so I got to get it alone, which means we have to add the 4 and then divide by the 2. So 2 times 3x plus 1 squared equals 54. 3x plus 1 squared, 54 divided by 2 is 27. Which means 3x plus 1 is plus or minus square root of 27. And again, I'm going to reduce that. 27 is 9 times 3, so that's plus or minus 3 square roots of 3. Finally, I got to get the x all by itself, so I subtract 1. 3x equals negative 1 plus or minus 3 square roots of 3. Divide everything by 3. X is negative 1/3 plus or minus square root of 3. Alright, last one. Don't let fractions freak you out. Some people see this problem, they go crazy, fractions, I don't know what to do. You do exactly the same thing. We've got the parenthesis, we've got the square. It's all by itself, so we square root both sides. P minus 3/5 equals plus or minus the square root of 19 over 25. That's plus or minus the square root of 19 over 5, because the square root of 25 down on bottom happens to be a nice number. And then you would add 3/5 to both sides. So P is 3/5 plus or minus the square root of 19 over 5. Now, since these have the same denominator, I would probably go ahead and write it as 3 plus or minus the square root of 19 all over 5, but it wouldn't matter. If you left your answer just like this, it is 100% correct, and you will receive 100% grade on it. And we kind of could have done the same thing on this one back here. This one, we could have written it this way, since they have a common denominator of 3. We could have left it as negative 1 plus or minus 3 square roots of 3 all over 3. I kind of like it this way better because I reduced the fractions a little bit. But again, if you write it like this, 100% full credit.